Hey everybody, Happy New Year. I was wanting to help everybody out with studying, and I also have a new toy to play with. This little writing tablet for my computer, so I thought I'd give it a whirl and maybe help somebody out. So, if you want to have a watch, please do. We're going to solve some Ramsey questions, and then later do some OLG questions too. So I'm starting with the midterm 2015 because it's a really vanilla Ramsey question that I suspect might be on the test because Ramsey was so long ago and she wants to be nice to us. So we're doing Ramsey. This is our utility function. It is normal. And this is our intertemporal rate of substitution, something like this. I forget the name of it. But yeah, that's just the normal one. And we have two assets as normal. We have technology, labor augmenting technology. So don't confuse that with the Romer model that has the endogenous technological growth. This is just in the production function, it'll be XL up here, f of kt x. They're calling it n, but it's L. Okay, so let's do A. I'm going to split it. We'll do this first part here, and then I'll do another little clip of the Hamiltonian and the Euler equation. So we're going to derive the intertemporal budget constraint for the household defining assets per capita. This is something you have to memorize, and I think it's on all of her exercises and tests. So it's very good to know. And we start with, what does the household make money from? They make money from earning a wage, and we're going to multiply that by how much labor they have, and then add to this, whoops, still learning how to use this thing. Add to that the amount of assets they have times the value of those assets, their rental rate. And then thinking about the evolution of assets over time, because this is where they get money from, and they store those money. They can do two things with this. They can accumulate assets, accumulate A, and they can consume it. And we're curious in the savings rate, which is this. Accumulation of assets in Ramsey equals savings. And remember, the big difference between Ramsey and Solo is that Ramsey has this endogenous savings function. In Solo, they just told you S equals point whatever. Whereas here, they're going to actually choose their rate of savings by choosing their rate of consumption. So we're curious in how do assets change over time. And we know that you can gain assets like this. This is everything that they get. And then from that, we'll just subtract everything they consume. And this is going to be, this is a big C. It doesn't look like it, but this is big. But we want it in per capita. They asked us to define little a equals A over L. So let's do that. Let's divide this by L. So on the left, it's going to look like this. And then here, we divide by L, and it's just W. And here we divide by L and we get little a, right? It's A over L. So W plus little a R. And then we had a big C that becomes a little c. So that's little. And we don't know this here. So we need to do the same trick we did in Solo when we were finding the law of motion of capital, which is to just take the derivative and see what falls out. I think of it like shaking the bag. So we take the derivative of the top times the bottom minus the derivative of the bottom times the top. And that's going to be all over the bottom squared. And we'll just split the fraction. So these L's cancel. And this, we know L prime over L equals N, the population growth rate, and A over L equals little a. And we also know that A over L is little a here, so we can write little a dot equals A prime, we defined up here. It's this one. This is A prime. And then A prime divided by L is actually this one here. So we can substitute that into this equation. Where's my color? So A prime over L is W plus AR minus C, and then here we had minus AC. And so we rearrange to find the law of accumulation of assets. Whoops, this is AN, I'm sorry. AN R minus N minus C. And that's it. So in the next little clip, we will do the Euler equation and the Hamiltonian.